This is a review of the TABE Math Level A questions, practice questions. Let's get started. Okay, which expression is equivalent or the same to x squared times y, and that's cubed times x to the third? So we need to make sure we know the rules of exponent rules. And basically, if it's like an exponent raised to an exponent, you're going to be multiplying. If it's an exponent with the same base, like say they're both x's, so you have the same base and you're multiplying them, then you can add the exponents. So let's look at the parentheses first. And we have x squared y to the cubed. So because it's an exponent raised to an exponent, we're going to multiply. So x squared to the cubed, so 2 times 3 is 6. And then y, it's y to the 1 because there's one y. 1 times 3 is 3. So we have y, y third, and that's times x to the third. Now, we can only combine the exponents of the bases that are the same. So x times x, 6 plus 3, remember if it's the same base, you're adding the exponents. So 6 plus 3 is 9, x to the 9, and then y to the third. So the answer is C. So if it's an exponent raised to an exponent, you multiply. If it's an exponent with the same base, you add them. All right, so here we have a list and it shows the measured heights in meters of trees in different sections of a forest. Section A, it's all about the same height, 4.8, 5.0, 5.3, 5.8, 6.1, 6.5, 6.5. So those are all between 4.8 and 6.5, like pretty consistent. Section B, we have 3.8, 3.8, 5.8, 6.4, 6.6, 6.8, and 9.2. So those range from 3.8 all the way to 9.2. Which statement makes a correct conclusion based on the interquartile range of the two data sets? So what's an interquartile range? These numbers are thankfully already listed in order from least to greatest, so that is very nice. Let's see, 1, 2, 3, 4, 5, 6, 7. There's 7 of them, so the number in the middle is the median. So 5.8 is the median and 6.4 is the median. And then if we were to look at the numbers like from here to here, or even from here to here, to get the interquartile range without having to do a lot of math, because I know the TABE test is a time test. But the important thing for this is to have the numbers listed from least to greatest, finding the middle number, and then looking at the numbers on either side of that. So which statement makes a correct conclusion based on the interquartile range of the two data sets? Well, for this, I would say that the trees in section A have a more consistent height than the trees in section B. Now keep in mind, I am thinking about like the outliers 3.8 and 9.2. that's a lot more varied in height than section A um, is. And if you were to like graph this out and plot their heights, you would see section A is like closer to a horizontal line, whereas section B is more of a diagonal line. B is not more consistent because it has a wider range from 3.8 to 9.2. Answer C says a randomly selected tree in B will most likely be taller. We don't know that because they kind of fall within the 5 to 6 range, but B also has a few that are in the 3 meter height, which would not be taller. And D says a randomly selected tree in section A will most likely be taller. We also don't know that because B has that 9.2, which is taller than everything in section A. So for this one, the best answer is section B, that section A has more consistent heights, which is pretty true across the board. Okay, rainwater collection system uses a cylindrical storage tank with a diameter of 50 centimeters and a height of 80 centimeters. What is the total volume that can be collected? So cylindrical means it's going to be like a soda can or, you know, like a round oatmeal container. Has circles as the base, right? And we're looking for volume. So volume is always equal to the area of the base times the height. And the diameter is the distance that's all the way across. So the diameter is 50 centimeters. To get area of a circle, we need the radius halfway across. So half of 50 is 25. So 25 is going to be the radius. And the height is 80. So from top to bottom, it is 80. So for our volume formula, the area of a base, the base is a circle, and the area of a circle is pi r squared times the height. And we know the radius is 25, we know the height is 80, so now we're going to plug in. So pi is, use 3.14 times the radius squared, 25 squared, times the height, which is 80. Let's do 25 squared first. 25 times 25 is 625 times 3.14 times 80. And that gives us 157,000 cubic centimeters. I feel like I missed 3.14 times. I'm double checking my work. It's probably because I used 3.14 for pi, but the answer is C. I might have needed to use like the full pi button on my calculator to get the correct answer. There's a loud motorcycle that just went by. I hope that wasn't too distracting. Okay. So a county clerk is given an amount of money to budget for cultural events, and we are shown a graph. And on the y-axis, it's the budget remaining, and on the bottom is the time in months. So if you look at the graph, it starts at $18,000, right? So at the very beginning, she starts off with $18,000, and at the end, after 40 months, there's no money left. So what does the 0, 18, what does this point right here mean? Well, if you're starting off with $18,000, that is the total amount of the budget given to the county. That's how much money they had to start out with to use and spread out over the entire time. That's the starting point. All right. An aquarium. At an aquarium, researchers are preparing a mixture of salt water. The desired ratio is 90 grams of salt per liter of water. And we have 1 ounce equals 28.35 grams and 1 gallon equals 3.8 liters. They want to know the ratio in ounces per gallon. So we're going to convert grams per liter to ounces per gallon. So I'm going to start with 90 grams per liter. That's what we're given right here. And I am going to go from grams to ounce. So I'm putting grams on the, times. I'm putting grams on the bottom so that it cancels out. So on the grams, 28.35 per 1 ounce. So I'm using this first proportion here. So grams and grams are going to cancel out, and I'll be left with ounces per liter. And 90 divided by 28.35 is 3.175 ounces per 1 liter. Okay, so I'm just going to rewrite this down here, 3.175 ounces per liter. And I want to go from liters to gallons, so I'm going to put liters on top so it cancels out, gallons on the bottom. And for every 1 gallon, there's 3.8 liters. So I'm going to multiply 3.175 times 3.8, and that gives me 12.06 liters per gallon. And I'm round that up to 12.1 liters per gallon. So just make sure with your proportions that you set it up so you can cancel out things, and make sure you're matching. If it says 1 gallon equals 3.8 liters, make sure the 3.8 stays with the liters, whether you put it on the top of the fraction or the bottom of the fraction. Okay, this is a 2-part question. On this slide is part A. Which expression can be used to find the zeros? And zeros is like where it crosses the x-axis, like the x-intercepts. F of x equals x squared plus 2x minus 3. And drag the correct factor into place to complete the expression. So we're given a formula for a parabola, and we're basically factoring it, right? So we know one part of the factor is x plus 3. And we know the second part is going to have x in it, and then either a plus or minus sign, and then another number. So let's think about this. If we have a -3 here at the ends, we know that our second number has to multiply to give us -3. So 3 times -1 is -3. And then if I were to do 3 times x and x times -1, that would give us our 2x in the middle. So x minus 1 is the other factor. So We know that our two factors are x plus 3 and x minus 1. So x plus 3, x minus 1, and those are going to be our zeros. So x is going to equal to negative 3, and x is going to equal to positive 1. And if we look at the graph of the parabola here, here's our x is equal to 1, and here is our x is equal to negative 3. So I would drag this one to right here, and then I would drag x equals 1 to right there. And those are the zeros where it crosses the x-axis. All right, Joan uses the function c of x equals 0.11x plus 12 to calculate her monthly cost for electricity. C is the total cost, x is the amount of electricity used. Which of the statements are true? Select the 3 that apply. So 3 of these are going to be correct answers. Make sure you pick all 3. Let's look at A. Joan's fixed monthly cost for electricity is 0.11. That is not true because usually a fixed cost is like plus something. So plus 12 would be the fixed cost. The 0.11 is like per kilowatt. All right, for B, the cost of electricity use increases 11 cents each month. That is also not true. The 11 cents is referring to 11 cents per kilowatt. C, if Joan uses no electricity, her total cost for the month is 12. That would be correct because no matter what, that's the fixed cost. So if you were to plug in 0 for x, 0 plus 12 would be 12. Okay, Joan pays $12 for every kilowatt hour. That is not correct. She pays 11 cents for every kilowatt hour. Okay, letter E, the initial value represents the maximum cost per month for electricity. Not sure about that one. Going to go on to the next one. F, a graph of the total cost for X is greater than or equal to 0 kilowatt hours of energy used is a straight line. Would it be a straight line if it was greater than 0? No, because it would be increasing. Okay, so G, the slope of the function C of X represents the increase in cost for each kilowatt hour used. G is definitely one of them. Basically, your graph is going to be going up. It's going to increase. So every kilowatt of electricity you use, your price or cost of electricity is going up. So say you're in Florida and you're running your AC a lot, that's going to use a lot of electricity and it's going to cost you more money on your electric bill. So let's review. We need to have 3. We know it's not A. We know it's not B. So the other answer has to be E. The initial value represents the maximum cost per month. It's okay sometimes to go back and review your answers. All right. Which of these expressions are equivalent to 5 squared? Select the 4 that apply. So here we're going back to our exponent rules. And if you're multiplying and dividing something with the same base, you're going to add or subtract the exponents. If it's an exponent raised to an exponent, you're going to multiply that. So let's look at A. We have the base of 5 and we're dividing. So it's basically saying 5 to the 5 minus 3, which is 5 squared. So A is good. For B, we're dividing with the same base, so we can subtract the exponents. 8 minus 4 is 4, so that's 5 to the 4th. B is not one of the answers. For C, same thing. 5 is the base, so we can subtract the exponents because we're dividing. 8 minus 6, so that would be 5 squared. So C is one of the answers. For the rest of these, we are multiplying. So that means we're going to add the exponents. So 5 to the negative 1 plus negative 2 equals 5 to the negative 3. D is not an answer. So for E, we have the base of 5. Negative 1 plus 3 equals 5 squared. So E is an answer. And then 5 to the negative 4 plus 6 equals negative 4 plus 6 is 2. So that is also an answer. So remember with your exponent rules, if you have the same base and you're multiplying or dividing, you add or subtract the exponents. You add when you're multiplying and you subtract when you're dividing. If it's an exponent raised to an exponent, then you multiply the exponents. And that is the end. I hope that this was helpful.